Okay, good evening. Can you hear me? Yes, you can hear me. Are you audible? Right. Send me message. Joel, everything okay, right? Okay, good. Okay, this is the second week of the, not actually second, third week of the January. We have another 1 week for this month and another 6 months. 6 months and 1 week for the exam. We have huge workload as I explained last Sunday. Okay, last week we discussed about resultant force. Resultant force. What's the meaning of the resultant force? A single force instead of force system, no? Resultant force. I hope you can remember resultant force. Resultant force. What's the meaning of the resultant force? A single force instead of force system doing same work as a force system. We discussed if two forces acting along same direction, P and Q, two forces acting along same direction, how to get the resultant force? R equal P plus Q, and resultant force direction same as force applied direction. Resultant force direction same as force applied direction. Today we are late 1 hour. Therefore, I hope to continue up to 10 or 10:30. Today, I'm going to complete our moment of forces lesson part, and that's the final part of the force. Finally, we have force equilibrium, moment of force, and a couple of force. That's the end of the force lesson. After that, I hope to discuss all model papers and all past paper. I have selected good questions. All past papers I have referred, all past papers and all model papers, term test papers. Yeah, I have lot of force lesson questions. I hope to discuss few of very important questions. I hope if time is limited, we have to go for next Sunday to complete force lesson. However, let's try to complete everything today. Yes, now two forces acting along. You have second exam. What is the date? Revision second exam 26. 26 or 7. 7th and 27 exam. 26th or 7? Six, no? No, 27. Yeah, 27. 26. I told 27 class exam. However, final week. You have 1 week for ready. Yeah, you have to go through our all theory lessons and especially for force lesson. Lot of questions based on force lesson. And you can try. This is the best method. You can improve yourself. Now you have first exam marks. First exam marks. Think it is 46. Example. If you got 46 marks, this is a good mark for first exam. No issue. If you got at least 40 marks, it's a good mark for first exam. But now second exam, third exam, you can improve. You can improve now. If you got 40, you can try for 50 now in the second exam. You can try for 50. Then third exam, you can 55. 55. If you got 55, if you got only 40, you are in the, still you are in S pass. Still you are in X pass. But if you can try 50 to 55 within short time, within 1 month, you can go to C pass. Okay, in this level, you can, if you want, you can try for B and A very easy. The main thing you have to try is convert into C. That's the most difficult limit. Make a then next part is easy. If you want A or B, easily you can reach these levels. That's the most important limit in your marks. Okay, let's try. Let's try. If you got 70, now you can try for 72, 73, and 75. If your target in 75. But if you got 40, don't keep target 80 or 90. Okay, you can't do. You can only very slowly you can improve. However, you have to, your path should be like this. Okay, okay, come to lesson. We discussed two forces acting along opposite direction. Then how to get the resultant force? P plus Q. That means addition. Add two or many forces acting along opposite same direction. Then add all forces. Then we can get the resultant force. Okay. Second option, second chance. Two forces acting opposite directions, P and Q. Greater value. Think P is the great minus Q. Resultant force direction equal to the greater force direction, greater value direction. Third one, two forces acting along perpendicular directions, P and Q. P and Q, this is the resultant force. This is P and Q. Then what is the resultant force equal? R equal P squared plus Q squared square root. P squared plus Q squared square root. P squared plus Q squared square root. How to get the direction? We can explain the direction by calculating angle. Calculating an angle. How to do it? You can use tan ratios, no? Tan theta. Tan theta equal opposite of adjacent. Opposite of adjacent, you have to careful. Opposite always think as a rectangle, right? Q over P. Q over P. Q over P. Then it is theta equal tan inverse Q over P. Tan inverse Q over P. Okay, this is our first equation. This is our second equation. This is our third equation. This is a direction equation of the two perpendicular forces. Resultant force of two perpendicular forces. Okay. Final one. Final one is the most important one. Two forces acting along different angles with different angles. How to get the resultant force? Think with different angles, normally less than 90-degree angles. Think it is theta. Now, how to get the resultant force? This is a resultant force. This is a resultant force. I told we can complete this two force as a parallelogram and complete get an the diagonal of this parallelogram is the resultant force. Okay, now we have equation R equal P squared plus Q squared plus 2PQ cos theta equal to cos theta square root equal to resultant force of this P and Q2 force. P and Q2 force, resultant force P squared plus Q squared plus 2PQ cos theta. P squared plus Q squared plus 2PQ cos theta. Okay, how to get direction? We can find any angle, no? We can find any angle. How to get it? How to get this angle? This is alpha, or any symbol you can use. I'm going to use tan alpha. Tan alpha equal, I told q sine theta over p plus q cos theta. This is the most important thing. I think you can remember. This p always angle side force. Angle side force is this single one without sine or cos. Sine angle and cos angle always multiply by the opposite side force. That's very important. That's very important. I need alpha. Alpha equal tan inverse q sine theta over p plus q cos theta. Okay, that's the final summary of the last week lesson. Final summary of the last week lesson. I am going to start today revising part. It is moment of force. Moment of force and couple of force. If we can cover moment of force and couple of force and discussed few questions, actually that enough for force lesson. However, we have next Sunday, I hope to schedule full force lesson question discussion. This is very important because in exam, මේවා තමයි very important lessons in exam paper. Electricity is most important lesson. Now we're doing in theory class. Electricity and fluid mechanism. We have 25 lessons. 25 lessons only. Fluid mechanism. Force. Fluid mechanism, electricity, force. Industry chemistry, natural product, industry chemistry, natural products, statistic, finally environment chemistry optional. If you want A pass, you should perfect. You have to perfect in all 25 lessons without any point in the syllabus. You have to perfect. But if you without 25 lessons, if you complete very perfect, complete perfect is 1, 2, 3, 4, 7 lessons, you can get more than C pass. You can score. Okay, they are very important lessons. Okay, now electricity lesson. Now we discussing in the theory class. Fluid mechanism still not discussed. Now force lesson. Now we doing in our revision class. Industrial chemistry and natural products. Upcoming theory lessons. They are very simple lessons. Statistic also upcoming lesson. Environment chemistry also. Very important. Now electricity, now we doing. Fluid mechanism still not completed. That's why I told this final 6 months is very important. Make up with this is the ongoing lesson in theory class. Fluid mechanism not complete. Force ongoing lesson in the revision class. Industrial chemistry, natural product, statistic, and environment chemistry. They are the most important lessons. Okay, more focus on these lessons. Actually, more than 40% of the syllabus from these 7 lessons. Very important. Make it without any small point. You should perfectly, if you can get super score for SIFT. Actually, your rank and your Z value mainly depend on your SFT marks actually, because BST and ET and other third subject all are same level, but same. Like if you got A pass, or B pass in 80, you can score maximum 78, 79. ICT you can get more than 80, but if you if you follow these lessons perfect for safety, you can, if you want, you can more than 90, you can score very easy. Very easily you can score. In MCQ part, you can get more than 48 MCQ, more than 90 marks you can score. More than 90 you can score. Therefore, it is very important for your Z value and district and iron rank. The moment of force. Do you remember what's the meaning of the moment of force? Moment of force. What's the definition? The moment of force. Moment. What's the meaning of the moment? Moment. Moment of force. Moment of force mean any object ability, the ability of any object or any lever. Think this is an object. If I apply an external force on any object F with some distance from its fixed point, the ability of this object rotate around any fixed point or reference point, that we called as a moment of force. That's a moment of force. The simply definition, the ability of rotate. The ability of rotate is the simple definition. The ability of rotate. The ability of rotate is the simple definition. The ability of rotate of any object around any point, around any fixed point or reference point. As example, think this is a lever, right? Think this is a lever. Now I have fixed this object from this end. Now I am going to apply external force. Now what happened? It's rotating. It's rotating. Now I'm going to fix point into this. This is a point. Now I am going to apply external force. Yes. Now it is rotating, right? This is the moment of force. The rotate කරන්න පුළුවන් ability එක. එහෙම නැත්නම් the lazy බව or difficulty or not. Okay, that's ability. Ability of rotate any object around its reference point or fixed point, we called as the moment of force. Called as the moment of force. The ability, this is the definition, the ability of some object around the given reference point, that we called as a moment of force. That we called as a moment of force. I think you all have tunes. If not, if anyone don't have tute, you can inform me. I'll send it. Yeah, I have, you all have, I think you all have tute. Yes, you all have tuned, right? Okay, what's the meaning of the moment of force? The ability of any object to rotate around any reference or fixed point. That's the meaning of the moment of force. Now, there are two factors affect on this moment of force. There are two factors affect on this moment of force. The first one, the first one, the applied force. The applied force is the first factor affect on this moment of force. And the ability of any object, its rotation. There are two factors affecting. The first one, the applied force. Applied force. Applied force. Applied force, capital F. Capital F. The second one, the second one, the perpendicular distance. The perpendicular distance. Perpendicular distance between force and fixed point. Fixed point. Okay, they are the main factors that we called as simple D. Okay, there are two main factors affect on the moment of force. Moment of force. What are them? Applied force and the perpendicular distance. These words are very important. Not the distance or displacement, it's perpendicular distance. These keywords, okay, they are the keywords. The perpendicular distance between force and fixed point. Force and fixed point. The perpendicular distance. This is applied force. The perpendicular distance means this force and the perpendicular distance always should have 90-degree right angle. That's the condition. That's the condition. Okay. Now, how to calculate this moment of force? We have a special equation. Before that, when increase the applied force, may force එක වැඩි වෙද්දී, when increase the applied force, what happened to the moment of force? Oh, that means moment of force being ability of rotate around reference point. No? Then this ability, what happened when increase the force? The ability, yes, definitely it's increasing. When we apply 5 Newton force, 5 Newton force, 5 Newton force, it's rotate in some speed. But if I increase up to 10 Newton, what happened? The speed is twice now. The speed increasing. The speed will be twice when we increase the force. Yes. Then when we increase the force, what happened? The moment of force increasing. That we call when yes. Yes, now when increase the applied force, what happened? The moment of force normally we called P, not pressure, it's moment of force increasing. Moment of force increasing, P increasing. That's we called as P, directly proportional to the moment of force. If the applied force directly proportional by when increase the applied force, the rotational ability increasing. Rotational ability increasing mean its moment of force increasing. Ability ekane moment of force can Then ability increasing mean moment of force increasing. Okay, what is our second factor? Second factor, when increase the distance between this reference point and applied force, perpendicular distance increasing, what happened? D increasing. The rotation ability increasing or decreasing? What do you think? What do you think? Joel? Dehini? When increase the this perpendicular distance between applied force and fixed point, what happened to the moment of force? Mean rotational ability. What do you think? Habib? Fatima? What happened? When increase the perpendicular distance from the reference point, the distance between when d value when increase this distance, what happened to the moment of force? What happened? Yes. Okay, you can very easily you can understand this one, this point by this example. Okay, this is a door. This is a door. This is the axis of the rotation. They are connecting. This is the connecting side, and this is a free side. It's rotate around this axis, right? The door rotate around this axis, around this axis. Now, A, B, C, D, A, B, C, D are 2 points on the door. Now see, now when if you try same force apply on D point, is it easy to open or close? Is it open? Is it easy to rotate this door around this axis? No, it is very difficult. No, you can try in your home. අපි මේ හරියෙන් අල්ලලා මේක අරින්න හැදුවොත්, or if you try to rotate, it is too difficult. It's too difficult. But if you come to C point and apply force, now little bit okay, but it's still difficult. Little bit okay, but still difficult. I'm going to apply on A point or very edge, on the edge point from the of the door. Then what happened? The distance increase, D increase, what happened? The rotation ability is increasing. D increase, the rotation ability is increasing. When increase the perpendicular distance from the reference point and the applied force, the moment of force or rotation ability is increasing. Rotation ability increasing. Okay, try to get the practical idea. Try to get practical idea. You can try to rotate your home door by this middle point and this type point, and normally the handle is connected to where? The handle connect to this edge. No, handle connect karan. What is the reason? To get maximum distance from the reference point, rotational axis, to get maximum distance, then easily we can rotate it. Okay, now I think you have full idea, practical idea. When increase the distance, the rotational ability increasing, P increasing, then P and this D directly proportional. Now both directly proportional. Now momentum equal, moment of force equal F into D. This is our final equation. This is our final equation. It is not the force into distance now. It is not the force of the force into distance. Force into distance correct in O level time. But now it is not force into distance. What is the equation? moment of force equal applied force, that's capital F, into perpendicular distance, not the distance, perpendicular distance, that's very important. Perpendicular distance between force and reference fixed point. Force and fixed point. Okay, that's the full equation of the full expression of the moment of force. Moment of force is the ability of any object to rotate around any fixed point. How we can calculate the moment of force? The moment of force equal applied force multiplied by the perpendicular distance into the between fixed point and the applied force. Okay, if you want, you can note down this short note. I can give 1 minute. Okay, now what is the unit of the moment of force? What is the standard unit of the moment of force? Yes, very good. It's Newton meter. Newton meter. Newton meter. It's Newton meter. How about evening climates in your area? It was rain. 6 to 7. In Columbus side, it was heavy rain. You know, I think I explained in theory class in heat lesson. Sri Lanka has four main rainfall patterns. One of the patterns. Fatima, they are doing in BST, right? Sri Lanka has four main rainfall patterns. What are they? Joel? What are the four main rainfall patterns? Sarnia? cyclonic rains, convectional rain. Yeah. No, I want normal. That's not I need. I need how many monsoon rains and how many inter monsoon rain patterns. Yes. That's for extra knowledge. They can be asked because nowadays the weather conditions, weather effects, they are very important. Normally we have 12 months, no? January, February, March, okay. This is our one annual 12 months. Normally February to no, May to September. What is this rain pattern? May to September. Yes, it is southwest. Southwest. Tapi nirita diga mawasama kiyanne. That is southwest. Southwest. Southwest monsoon. It's a monsoon rain. Monsoon rain. Monsoon. Southwest monsoon. December and up to February. What is this? December, February. What is this? Northeast, no? Northeast. Monsoon. Okay, we have two monsoon rains. And between them, you can see March, April, and October, November. They are free areas, free time, free period. They be called as intermonsoon rains. Intermonsoon rains mean the time period between two monsoon. After northeast monsoon, March, April is the first intermonsoon. That's the first intermonsoon. First intermonsoon. Intermonsoon. First intermonsoon. This is second intermonsoon. Intermonsoon. Do you remember in heat lesson I explained about this intermonsoon time always raining at evening time after 2 p.m. After 2 p.m. What is the reason? The reason that's the rain is coming due to convection. That we මේවට අපි කියන convectional rains කියලා. Convectional rains කියලා. Then Joel's convectional rains and intermonsoon rain same. Not two types. මේ intermonsoon time එකට තමයි convectional rains එන්නේ. Convectional rains mean in daytime very hot in daytime. And after 2 p.m., after 1:30 or after normally 2 p.m., 2, 3 after evening time, heavy rain due to convection. Convection I explained due to density difference, air molecule, water vapor go to up, water vapor going upward in the atmosphere, and they condense and make clouds and form as a in the evening time. What happened? Rain, thundering, heavy rain with thundering. What is the time now? Today, what is the type of rain today? Rain, it's a intermonsoon. But what is this month? January. What is the reason? What's the reason? Yeah, they are as technologists, they are the point you have to focus. No, normally intermonsoon. Now October, November time, this type rains. Okay, this is the usual time. But why in January? Fatima, I think you are learning there. No, any idea? What is the reason for that? I hope this monsoon rains, as I remember, I explained monsoon rains very simple. Monsoon rain mehema wenni. Monsoon rain time, convectional is not affecting. Convection is not affecting in monsoon period. Monsoon neke mehema wenni. This is the think it is the earth. Now this is the and this is a north pole and this is a south pole. And this is Sri Lanka. Now, in this southwest monsoon time, May to September time, what happened? May to September time, the North Pole pressure decreasing, South Pole pressure increasing than that. This is no natural scenario, natural pressure changing in the earth due to sun effect and everything affecting, but that's a natural case. Okay, now what happened? All wind, what happened? They are going from North Pole to South Pole. Wind එක මෙහෙට තමයි direction එක. This is a wind direction. North Pole to South Pole. Now what happened? Huge water vapor carry into the Sri Lanka. That's why in the center mountain system, they act as a barrier. Due to that, they going upward and make as cloud. That's a southwest monsoon. Northeast monsoon mean pressure change into opposite direction. Pressure change to opposite direction. Mehe pressure decreasing, then north side. Now what happened? Air wind එක මෙහෙට තමයි. Due to that, in Sri Lanka, it's coming insert this wind in northeast monsoon. It's carry huge water vapor and make clouds and form rain, precipitate rain. Now, what's the meaning of cyclonic effects? Now, last month, cyclonic effect means this pressure variation always showing in pole regions, but close to Sri Lanka, there is a pressure that we call as low pressure area. Low pressure area generating close to Sri Lanka. Now what happened? All water vapors, all wind come to this low pressure area, high pressure area to low pressure area. Then it's carry lot of, it's retain huge water vapor, and that's why unexpected rain came to Sri Lanka. They are the reasons. Okay, that's not my question. My question, how it is changing? Any idea? My question, how January months coming into monsoon rains? What is the reason? Dihini, I think you are learning there. What's the reason? No, any idea? No idea? They are very important for our final lesson. That's why I asked. Rehlan? The reason, climate changes are the reason. Climate changes mainly by human activities. Human activities due to in the final lesson I will show you in environment chemistry. In environment chemistry, we discussing in environment chemistry we discussing different types of effects, human effect, how effect for our climate system, and how they affect for acid rains, how they effect for the global warming, and this type rainfall pattern changing. Sometimes now due to human activities, due to different gases released to our harmful gases released to our environment, sometimes the southwest monsoon start end of July. End of July. What is the main problem? This is main problem for our agricultural field, because normally we are, we have two cultivation periods, no, Yala and Maha. With changing of this rainfall pattern, everything will be changing. Normally it is mainly affect to the yield, annual harvest. You know what is a අපි කියන්නේ යාල period කියන්නේ මොනවද? මෙන්න මේ ටිකට. This is a යාල කියන්නේ මේක. With December, this is the month. Okay, that's there in Sri Lanka. Normally in rice cultivation, we have two periods, cultivation periods, Yala and Maha. Hari, that's extra thing. They are very important for our final lessons. That's why simply I am explaining this, how to rainfall pattern changes, human activities, how to affect human activities. Then if you have basic idea, in final days for final 25th lesson, environment chemistry 25th lesson, that we're doing in final 2 months. It's a very simple lesson. That's why I explained the actual scenario in the world. You should have idea actual scenario and actual problems in the world now for this lesson. That's why I always explain. Okay, Hari, compilation. Okay, what's the meaning of the moment of force? The ability of rotate any object around fixed point or reference point. How to calculate it? How to calculate it? Applied force multiplied by the perpendicular distance between applied force and fixed point. Okay, let's go to a calculation. Okay, first example. Take a paper and let's do first example. First example. Okay, quickly calculate the moment of force around O point. The moment of force around O point. The moment of force around A point. Okay, send your answers. Don't take time today. We need to complete this. Okay, F into D, no? Simple. The applied force 50 Newton. The distance, the perpendicular distance, no issue, no? It's perpendicular. Perpendicular distance between reference point and the force, it's 70 centimeter. Then convert into meters, divide by 100. Now it is 270 over 2, 35 Newton meter is the moment of force. 35 Newton meter is the moment of force. 35 Newton meter is the moment of force. Second one. Second one. Okay, calculate the moment of force around a point. Calculate the moment of force around a point. Calculate the moment of force around a point. Dihini, what's the value? Amina? I need moment of force around O point. Okay, what is the equation? F into D, right? F into D. Moment of force equal applied force into perpendicular distance, not distance, perpendicular distance. Now applied force 100, okay, but is it perpendicular distance? It's not the perpendicular distance. It's not the perpendicular distance. Then what to do? Yes, we can use force resolution, right? We can use force resolution to get the perpendicular distance. Okay, I'm going to resolve this force into perpendicular direction. Okay, if I got this component in the main component then it is perpendicular. No, now it is perpendicular. Now it is perpendicular. Okay, what we can do for this? Okay, 100 resolve into this direction, not into angle direction. I'm going to resolve it in this direction. Okay, what is the method? 100 angle direction cos theta. You know, angle direction cos theta. Now, other direction sin 30, sin theta, sin 30. Now, 100 sin 30, 100 sin 30 mean half, no? Sin 30 mean half, then it is 50. 50 Newton is the applied force. Applied force 50 Newton. 50 Newton is applied force. The perpendicular distance now, okay, now it is perpendicular distance. Perpendicular distance, fixed point and the force 2 meter. It's 100 Newton meter. 100 Newton meter. 100 Newton meter. Always, that's why in O level time you don't know about force resolution. That's why you use force into distance, but now you can't use force into distance. Applied force into perpendicular distance between force and applied this reference point, fixed point, force and reference point. And okay, let's do final one. Third one. Third one. Okay, calculate the moment of force around a point. It's Newton, sorry. Okay, quickly send your answers. Yes, good. Joel, check again. I think that's a mistake. Others correct that. Okay, let's start. How to do it? First, we have to resolve it into perpendicular direction. What's my perpendicular direction? This is a perpendicular direction, right? Okay, I'm going to resolve this given force into this direction. Now it is perpendicular. Now it is perpendicular. Now moment of force around O point, F into D. Applied force 880 root 3. And now we're going to resolve it into opposite direction from the angle. Then it is sine 60. Sine 60 into the distance between 2 points. It now perpendicular distance. Now it is correct. 20 over 100. 20 over 100. 80 root 3 sine 60. 80 root 3 sine 60 value, you know, root 3 over 2. Root 3 over 2. Sine 60. Sine 60 root 3 over 2. 20 over 100 mean 0.2. No? 0.2 ne api eka damu for easy calculation 2 over 10. Now 2 to 2 cancel. 2 to 2 cancel. Root 3 into root 3. What happened? Root 3 into root 3, it's 3. And 0 to 0 cancel. Root 3 into root 3, 3. 8 into 3, it is 24 Newton meter. It's 24 Newton meter. Joel, root 3 into root 3, 3 venom. That's a mistake I think you have. Okay, complete. Amina, correct? Harida? Okay, let's move into the next part of the lesson. Now you have full idea what's the meaning of the moment of force and how it calculate applied force into perpendicular distance between force and fixed point. Okay, let's move into next part, the equilibrium of moment of force. The equilibrium of moment of force. This note you can read, or direction of moment of force. No? Direction of moment of force. Okay, direction of moment of force. Now its rotation. Actually, rotation. We have main two rotation directions. They we call first one direction of moment of force. Direction of moment of force. Okay. Now this is F1 and this is D1. This side D2 and applied force F2. F2. This is a point O. O is the fixed or rotational point. This is a fixed point. Okay. Now, that's the most important thing you need to understand. Otherwise, if you not understood this direction well, you will trouble in our complex calculation. Now, I am going to conduct. We are going to discuss little bit advanced calculation part and exam question. They always ask in standard level. I will show you today exam questions. Okay, now what's the meaning of moment of force? The rotation ability of any object. Now rotation ability, if it is rotation ability, the rotation directions mainly two. You know, always what is the direction of the clock? What is the direction of clock? Up what is the direction of clock? What's the direction of the clock? Into this direction, right? Into this direction. Clock ke direction hai? This is the clock direction. right? Into the right hand direction. My right hand direction. This is a clock direction. This direction we called as clockwise direction. Clockwise direction. Clockwise direction. Clockwise direction. Then if you got opposite direction, this is opposite direction, right? This is opposite direction. This is the opposite direction into my left hand direction. Left hand direction. හරිද? මෙහෙම බලවම left hand direction. ඔයාලගේ book එක දිහා බලවම left hand direction. Left hand direction. What is the name? It's anti-clockwise or counterclockwise direction. Anti-clockwise direction. Anti-clockwise direction. Okay, please in your mind store what is this direction into your right side, into your right hand direction, rotating it's clockwise. Into your left hand direction it's anti-clockwise. Okay, clockwise and anti-clockwise. If not clock direction, clockwise, other direction anti-clockwise. Hari. Okay, now if you got this, if I rotate this lever from O point, can you tell me what is the clockwise moment of force? Clockwise moment of force. Clockwise moment of force. What is the clockwise moment of force? Okay, you forget about this left side. Okay, I'm going to rotate this object from F2. F2 again, විතරක් හිතන් think only about F2 force. Now what happened? What is the direction of force? What is the direction of moment of force? It is clockwise, right? Why? Then make a මෙහෙම හිතන්න මේ. Due to this force, it's rotate මේ direction. That's why we consider it is a clockwise direction. But sometimes you doing mistake, it's rotating to මෙහෙම හිතන්න. Left side. Not, you have to think full rotation like this. Understood? Girls especially doing this mistake. Sarmya, understood? You have to think only, don't think about half rotation, full circle you have to think. Sarmya, understood? And Amina, Fatima? Dihini? Yeah. Think full rotation. Full rotation. Now it's rotating to right side direction. No? Then it is clockwise moment of force F2 into D2. Clockwise moment of force F2 into D2. Now anti-clockwise moment of force. Anti-clockwise moment of force. Anti-clockwise moment of force. Anti-clockwise moment of force. Now you have to think this way. This way. Think, don't forget about this right side direction. This is a rotational point. Now it's rotate in this way. This is a rotational point. It's rotate this direction, right? Now that we called as F1 D1. F1 D1 equal That is the anti-clockwise moment of force. Anti-clockwise moment of force. Anti-clockwise moment of force. Okay, that's the direction of moment of force. Now, according to direction, we have two type of moment of forces. Clockwise moment of force, object rotate into clockwise direction. Anti-clockwise moment of force, object rotate into anti-clockwise direction. Anti-clockwise direction. Okay, now let's move into our final part of moment of force, direction complete. Now, if you have new theory, you can complete is clockwise moment of force, anti-clockwise moment of force, you can complete according to the given diagram. Now, next part. Final part. Equilibrium under moment of force. Equilibrium under moment of force. Okay, equilibrium under linear motion, that we already discussed in the Newton's law. Okay, equilibrium mean what? Equilibrium object explained in the Newton's first law, right? Newton explained if any object is rest or if it is moving, sorry, if there are no any unbalanced force act on any object, it's rest or moving with uniform velocity. Uniform velocity. That's a Newton's first law. If there are no any unbalanced force act on any object, this object is moving, this object, rest object, it's rest and moving. If it is moving, it's moving with uniform velocity. This is a Newton's first law. Actually, he explained full details about equilibrium object in linear motion in the Newton's first law. Okay, but what's the meaning of the linear motion equilibrium? Linear motion equilibrium means don't have unbalanced force or don't have resultant force. If it is resultant force 0, we call it as in linear motion object is balanced. If there are no any unbalanced or resultant force. But in moment of force, now object is rotate. This rotating object what we call as equilibrium. Equilibrium. Moment of force. Rotating objects. Remember, if any object equilibrium or if any object balance, the balance mean equilibrium. If any object balance, if any object balance or equilibrium, what happened? Balance, what happened? Clockwise, the sum of is very important. The sum of clockwise, the sum of clockwise moment of force equal to the sum of anti-clockwise moment of force. Okay, that's a very simple theory. If any object balance or equilibrium, its clockwise sum of clockwise moment of force equal to the sum of anti-clockwise moment of force. That is a simple equation of the equilibrium of rotational object. The sum of clockwise moment of force equal to the sum of anti-clockwise moment of force. Okay, according to the previous relationship, now we can get if it is balanced, if this above lever is balanced, if it is balanced, if lever is balanced, or equilibrium, you know clockwise moment of forces equal to the anti-clockwise moment of forces. Therefore, we can say F1 F2 D2 clockwise moment of force equal to F2 F1 D1. F1 D1. Okay, this is the relationship we can get by in the lever, in this lever. F2 D2, that means clockwise moment of force equal to the anti-clockwise moment of force. Okay, that one also very important. The final point. Now, if it is equilibrium, what's the condition? If any object equilibrium or balance, what is the condition? Its clockwise moment of forces equal to the anti-clockwise moment of forces. We can say the same thing. We can explain the same thing in different way. See, F2 D2, that's been clockwise moment of forces. Now, if I got, that's very important. If I got F2 D2, F1 D2, if I got into same side, it's minus F2 D, F1 D1 equal to 0. Equal to 0. Can you see? First equation and this final equation, it is same thing explained. No, same thing. Now we call, if you got clockwise moment of forces plus values and anti-clockwise moment of force plus minus value, that's we called as geometrical sum, geometric sum. So when we were clockwise moment of forces plus and anti-clockwise moment of forces minus substitute. Then the summation we called as its value 0 if it is balanced. If it is balanced. Okay, if you want, you can make a short note. Can give you 1 minute. Okay. Complete. No, I think you have full notes now. Okay, let's go to our basic calculations. Okay, I'm going to one by one up to maximum standard questions. Okay. Okay, let's start very simple level. Question part number 1. Okay. Can you get this? F. What is the value of F? If above lever is, if above lever is balanced, what is the value of F? What's the value of F? If above system is balanced, calculate the value of F. Okay, I got. What's the value of F? What's the F value? What's the value of F? Okay, how to calculate? Now the system already balanced. Now at equilibrium is a correct method to get this type answer. At equilibrium, balance mean equilibrium. At equilibrium, at equilibrium, clockwise moment of force is equal to the anti-clockwise moment of force. Okay, I think clockwise moment of force, F into 15. F into 15. F into 15. Can you use 15 or you have to convert into meter? Do I need to convert into meter? Joel, what do you think? Required or not? Yes, both sides in centimeter. If it is both sides centimeters, you can Substitute in centimeters and you can see centimeter cancel out. 15 to 20 centimeter. Now centimeter to centimeter cancel out. Therefore, this type questions, it's no problem, but you can't, moment of forces you can't find by centimeters. Okay. Now 15 to it is 3, 4. Now 3F equal 200. F equal 200 over 3, 66 point value. 66.67. Yes. Newton. Newton. Okay. Let's move into second example. Okay. Second one. Complete this quickly. If you have any mistake. If you want, you can convert into meter. Same answer, no issue. Because meter centimeter cancel out. Second one. No, Newton. Newton. Okay. Same question. If this lever is balanced, if this is if above lever is balanced, calculate the x distance. If above lever is balanced, calculate x distance. Okay, quickly calculate. It is not 20 meter, 2 centimeter. Left side length 2 centimeter. 2 centimeter. Okay, what is the length? What's the distance? X distance. Quickly get this. Okay. What's the distance? Yes, very good. All are correct. Okay. How to get it? Same method. If it is equilibrium, at equilibrium, clockwise movement of forces. Clockwise mean 48 into x. F into d. 48 into x equal 30 into 2 centimeters. Now you can substitute in 2 centimeters, but remember always answer coming in substitute centimeters now. If you want meter answer, you can convert this value into meter. Okay, now I want x value, x into 60 over 48. What's the 60 over 48? 1.25. 25 centimeters. 1.25 centimeters. 1.25 centimeters. Okay, third one. Okay. Yes, then we are complete this part up to 10 p.m. Yeah, you can find this video in our website. I will upload today after 2 hours. Before 12 p.m. I can upload into this month course page. Okay, the system is balanced now. I want what is the value of f? Value of f. Okay. What is the F? Okay, how to calculate? Same method. Same method. Now, clockwise moment of force equal to anti-clockwise moment of force at equilibrium. At equilibrium. At equilibrium. Clockwise moment of force, we have to resolve it into this perpendicular direction. Into perpendicular direction. We have to resolve it into perpendicular direction. Now this is the F. We have to resolve it into perpendicular direction. How to resolve F? Not cos theta, sin theta, because not into angle direction. F sin 60 into 5 meter equal 30 in 30 Newton into 3 meter. Now F sin 60. F sin 60, what is the value? Root 3 over 2 into 5 equals 90. Okay, now you can isolate the F. How you can isolate F? Cross multiplication. Cross multiplication. Root 3, 5 root 3 into F equal 90 to 180. 180. Okay, my target, calculate the F. F equal 180 over 5 root 3. You can use calculator. Send your answer. F equal 180 over 5 root 3. Dihini, what is this value? 180 over 5 root 3. What is this value? 20.78. Yes. 20.78. Yes, 20.78. Very good. Newton. Okay. Let's go to bit advanced calculation. More than 2 forces now. Okay, last 2 questions. Okay, this is the force system. Now this is a balanced force system. It is equilibrium. I want to calculate F. Okay, quickly calculate. If you can manage this type question easily, you can manage exam questions. Now what is the equation? The sum of anti-clockwise moment of force is equal to the sum of clockwise moment of force. I can give you 2 minutes and send you answer. Complete. Okay, what is value? What's the value? F. Okay, how to calculate? First, you have to find what are the clockwise forces and what are the anti-clockwise forces. What are the clockwise forces and what are the anti-clockwise forces? Okay, now this is first 8 Newton. It is clockwise, right? Rotate in this right direction. 2 Newton anti-clockwise. 15 anti-clockwise. F clockwise. Anti-clockwise, clockwise, anti-clockwise, clockwise. First you have to mark these directions. Now, if it is balanced, what is the condition? The sum of clockwise moment of forces is equal to the sum of anti-clockwise moment of forces. Sum of clockwise moment of forces equal to the sum of anti-clockwise moment of forces. Okay, now what is the method? Sum of clockwise moment of forces. Now clockwise, F is clockwise. F into 3 plus 2, it is 5. The distance, this is a rotational point. It's 5, not 3. Okay. The total length 5. It is clockwise plus. We have another clockwise 8. 8 into 1 plus 2, it is 3. It is equal to anti-clockwise, sum of anti-clockwise moment of forces. Sum anti-clockwise 2 into 1. 2 into 1 plus 5 into 2. 5 into 2. Now you can isolate the F. 5F equal, 5S plus 24 equal 2 plus 7. It's 9. Two plus 7. 9. 9 minus 24, it's a minus value. 5F equal 9 minus 24. 9 minus 24 mean what's the value? F equal 9 minus 24, 15, no? Minus 15 over 5. Don't think about this minus value. 15 over 5. It is 3, no? Sorry, it is not 10. Sorry, mistake. 5 into 2, it's 10. It's 12. Sorry. 12. 12 minus 24, it is minus 12. Minus 12. 12 over 5. 12 over 5 is the answer. 2.4. Newton. 12 over 4 Newton. 12 over 4. They are very important for your exam questions, to discuss exam type questions. Okay, understood, Dihini? Sarmia? Are you good? Sarmia? Understood? Okay, if you can if you can find these directions, you have another very short method. Okay, that's why I told the geometric sum of geometric value, it's 0. Okay, that this method you can use if you can identify directly. Okay, I will show you the same question, the geometric method. Okay, now I told the clockwise moment of force is equal to anti-clockwise moment of force. This anti-clockwise, if you got in minus values, see, anti-clockwise, if you got in minus value, what is the value? It's 0. Okay, this method you can use for this same question, this type more than 2 force questions more than 2 force. Okay, now you can start from any end. Okay, I'm going to get moment of force around O point. Now 8 Newton. 8 Newton clockwise or anti-clockwise? It's clockwise. Therefore, it is plus 8 into 3. It is plus value. Minus 2 Newton anti-clockwise. 2 Newton anti-clockwise. Therefore, it's minus 2 into 1. That's a very short and easy method. Now, 5 Newton anti-clockwise, again minus 5 into 2. 5 into 2. F clockwise, it's plus F into 3 plus 2, 5. It is equal to 0. It's equal to 0. Okay, that's the same method. You can easily get the equation, right? Relationship. Okay, it is 24 minus 2 minus 10 plus 5f equals 0. Now 24 minus 2, it is 24 minus 2, it is 22. 22 minus 10, it is 12. 12 plus 5f equal 0. Now I can get this 12 into this side. Now 5f equal minus 12. Then f equal 2.4. Okay. Same answer you can get by this method as well. Okay. Homework. Okay, you have 2 homework questions, very easy questions. And next week, next Sunday lesson, today we don't have time to discuss exam questions. Next Sunday, very important class for you. Therefore, don't miss it. We're going to discuss all exam question and model paper questions of first lesson. And we complete, that's the final day of first lesson. And next Tuesday, I hope to discuss this daily refresh papers and complete January month works. After exam, I am going to discuss exam paper. Okay, homework questions. Calculate this x distance if it is balanced. The system already balanced. I won't calculate the x distance. What is the x? If it is balanced, what is the x? This is my first homework question. Yeah, you have time. You have 4 days. You can try those questions. Okay. First question, if it is system balance, calculate the x value, x distance. Second question, if this system balance, calculate the F value, F force. Calculate the F force. Calculate the F force. Calculate the F force. Now, convert it into 50 Newton. No, 100 Newton, correct? 100 Newton. Not 10, it's 100 Newton. This is 30 degrees. 30 degrees. Okay, quickly draw it. Okay, complete homework questions. Amina, are you completed drawing? Okay, then practice those questions and come to next Sunday. Next Sunday, very important. And tomorrow we discuss very important part of the electricity lesson. Don't miss it. Going to discuss resistance system in tomorrow. Most important and a bit advanced part. And lot of short method we discussed in tomorrow class. Electricity resistance systems. And next Sunday, I'm going to explain or discuss all force lesson application questions. I will send you those questions before Sunday. Day after tomorrow, Thursday, I will send you. Then you can try and come to Sunday class. Okay. Do you have any question, doubt? Today lesson? Okay. If not, let's meet tomorrow evening, 6:30. Goodbye.